Find the derivative of the function f of x equals the square root of 1 minus 2x at the number a. Again, we're going to use the same limit definition for the derivative, which we have right here. And we just need to plug in our new function here, f of x equals the square root of 1 minus 2x, and do some algebraic manipulations to get rid of that h in the denominator. We can't have that h there because then if we try and plug in h equals 0 with direct substitution, we've got undefined, can't do it. So that is why we're using all of the algebraic manipulation here. So let's start by actually plugging in the specific function that we're working with here. So f of a plus h, we're going to plug in a plus h for x. So that's going to be 1 minus 2 times a plus h. I'm just going to distribute that 2 now. So 1 minus 2a minus 2h. I think you can do that in your head. I don't think it'll be a problem. I just want to save us a step whenever we can because we are writing out this whole big fraction with the limit over and over again. And it's nice every once in a while to write it down one less time. So we've got minus f of a. That's going to be the square root of 1 minus 2a. And this is all over h. Now, we need a trick that we're going to be able to use to get rid of the h in the denominator. And there is a trick that will often work when we have a difference of two radicals. What we want to do is we want to multiply the top and bottom of this fraction by the sum of those radicals. The reason we're going to do that, we know that a difference times a sum is going to give us a difference of squares. When we square a square root, those cancel, and those radicals are going to go away, and we're going to end up with an h in the numerator that can cancel with the one in the denominator. It's going to make life easier. So let's do that. This is going to be 1 minus 2a minus 2h under the square root plus the square root of 1 minus 2a. We've got to multiply the denominator by the same thing. Perfect. When we multiply the numerators, we are going to have a difference of squares. If we FOIL things out, the outer and the inner ones are going to cancel, and so it's just going to be this first one squared minus the last one squared. And we know that when we square a square root, that gets rid of the square roots. So it's going to be this first bit, 1 minus 2a minus 2h, minus that last part squared. If we take the square root of 1 minus 2a and square it, the square root goes away. So we've got 1 minus 2a, but I'm still going to use parentheses because we've got to subtract that whole shebang. And then this is going to be over a nightmare. Just kidding, it's not a nightmare. It's h times the sum of those square roots plus the square root of 1 minus 2a. It's a lot to write, but it's going to be fine in the end because we're going to let h be 0. Life's going to go on. Lots of things are going to cancel. Life will be good. So in the numerator, we're going to have to distribute those subtractions. And what's going to happen is we're going to have a negative 1 here and a positive 1. They're going to cancel. And subtracting a negative is going to turn this into a positive 2a, and it's going to cancel with that negative 2a. So in the end, the 1s are going to cancel, and the 2a's are going to cancel, and we're just going to be left with this negative 2h, which is beautiful. So we've got our limit as h approaches 0. The numerator is just going to be negative 2h. The denominator is going to have that h in it, and then the sum of these square roots, which I am writing out now. And then we've got factors of h that cancel in the top and bottom, which is wonderful. That gets rid of that h down there. And then these two things, if we plug in h equals 0, we're not going to have a 0 in the denominator. And so we will be able to use direct substitution here. So let's substitute in 0 for h. We've just got negative 2 in the top. And then in the bottom, we don't need these parentheses anymore because that h is gone. There's no more multiplying to do. So when we plug in h, when we plug in 0 for h down here in the denominator, this is just going to be the square root of 1 minus 2a, because that h term is going to vanish, plus another square root of 1 minus 2a. And whenever we have anything plus itself, that is just 2 times that thing. And so our denominator is going to be 2 times that square root of 1 minus 2a. And that's our denominator. Our numerator is negative 2, and we can cancel out the 2's. We can divide the top and bottom by 2. We've got that common factor. I'm going to pull the negative out front because I think it looks better. We're left with 1 in the numerator because that 2 canceled. And then we've got the square root of 1 minus 2a in the bottom. And this is our derivative. If we wanted to find the slope of the tangent line at any point, any x value of a, we could plug in that value here. We would get this number for the slope, and then we could plug it in to point slope form. If we were using this derivative to find a velocity, if this was a position function, we can just figure out what that value of a was that we're given, plug it in. We've got our velocity. Boom, we're good to go.